am Pelumi from Pythagoras Consult. We are on to our mathematics SS2. Like I do advise SS3 to watch it for proper update. In last class, we have arithmetic progression, under series and sequence. So now we'll be having geometry, that we all known as what? GP. Another name for geometric progression is what? Exponential sequence. We call it exponential. You know, AP is also called linear sequence. So this one is exponential. So sometimes they may not call it GP, they call it exponential sequence. So what is GP all about? GP is a sequence. It is a sequence with common ratio. Like we have AP is common difference. This is common ratio. Now let's give example. Let's say we have 2, 4, 8, and like that. So to know the common ratio is denoted with R. So to know my R, which is the common ratio, let me first locate this. First term there is 2, of course. We have second term, which is 4, and we have third term, which is 8. So to get my common ratio, you are going to have, I'll start from second like I do subtract. AP deal with subtraction of first and second. Why this one is what they call it ratio. Ratio means to divide. So it's going to be second term divided by the first term. In order for you to check if this is correct, you still have third term divided by the second term. So if you still want to check further, you still have fourth term divided by the third term. So this is how to get the common difference. Now let's look at the common difference of this sequence. The second term is 4. The first term is 2. So that gives me 2. 2 divided by 4, 2. Okay, let's say or the third term is 8. Why the second term is 4. If you still divide it, it still give me 2. So meaning that I can get the fourth term. So my fourth term is very simple. We'll just do what do we do? We have our third the common difference, the common ratio is 2. So 2 times 2, 4. That because we divide. So in order to proceed to the next one, it will be multiplication. So 2 times 4, 8. So the next fourth term will now be 8 times 2, which is that term, third term times 2 is giving me 16. So like that, multiply by 2, multiply by 2. That is why in economics, they agree under Malthusian theory that human population increase at geometric progression, while food will increase at what? The assumption of Malthusian theory. It will increase arithmetic. So arithmetic is by step by step, 1, 2, 3, 4, not just slow increase. Why geometric is what? Fast increase. Now let's look at the formula. We know that the first step is always denoted by what? A. Denoted with A. Then, if I want to get, ordinarily the general rule of the nth term of a geometric progression is n raised to power n minus 1. Raised to power n, AR raised to power n minus 1. So this is your first term, this is your common ratio, this is number of term. So A is what? first term. R is common ratio, while N is what? Number of term. So very simple. Probably you may be using it. Probably you can make use of another. If first term of arithmetic geometric progression is A, so the second term will be A multiplied by the common ratio, and that's what we did here. We multiply the ratio with it to get the next term. And I said the common ratio is 2. 2 times 2 is to give me the second. 2 times this, like that. So the third term will be the first term multiplied by r in power of 2. This one is in power of 1. So there will be reduction in your term with the index here. So the fourth term, you reduce this one by 1. So r raised to power what? 3. So the fifth term, so I'm giving you this in case of objective. Ar raised to power what? 4. This just reduced by 1. Anyway, let's look at some examples. Let's go through this. First and the third term of a GP are 1 and 9 respectively. What is the second term? So this is a kind of why question. So they said the solution. The first term, which is A that we normally see, is 1. And the third term is 9. Now, how do we get our common difference? We don't know. So, but mathematics is a subject that will go from known to unknown. What is sure for us now is the third term that we not completed and we know the first term. So we start from that place. Our third term is ordinarily, look at our third term that I've done here. Third term, just apply that. So you are saying a raised to power ar raised to power n minus 1. This is 3, which is ar raised to power 3 minus 1. And that's what ar raised to power 2. So that's our third term. So if our third term is ar raised to power 2, like I said, you will do this one by 1. They are giving us our first term to be 1, but we don't know multiply by our common ratio. But they said that third term is 9, so we substitute it 9 here. So the meaning is that our 9 now is equals to r raised to power 2. Now, in order to cancel this, we take square root. Like I do tell you that square root cancel what? Square. Although it's going to give this number positive or negative. Rather, we need the positive. We need the positive since first time is 1. So it's going to give us something like this. Root. This one will be plus or minus normally. Root. So you take the roots of both sides. And it's good in case of y that you write it there. You say take root of both sides. So this cancel this. My r now is equals to is plus or minus 3. Of course, I will choose the plus. Because why am I choosing the plus is that my first term is 1, so it can't go back to negative. So thank God I have gotten my common ratio. I can now look for the second term. Very easy. They asked me to look for the second term. The second term will now be, normally is r 2 minus 1, which is what? R raised to power ar raised to power 1. Fine. So I know my first term to be 1, my common ratio to be 3 raised to power 1. So it's the same thing as what the second term will be 3. So let's still have more example. This question is also an echo question and very interesting. Given that this sequence root 6, 3 root 2, 3 root 6, 9 root 2 are and the likes are this first 4 terms of an exponential sequence. So they are the when I say exponential sequence, I told you that time they may call it exponential, they may call it geometry. So find its simplest form. In its simplest form, the 80th term. So first thing that will come to our mind, we know our first term. We know our first term. Our first term is what? Root 6. We need what? Our R, common difference. We don't know that. So let's get that first. Let's get that. And our R is what we say common ratio, second term divided by first term. Now let's look at what's our second term there. Our second term is 3 root 2. So 3 root 2 divided by our first term is root 6. So you not leave it like this. The sort that we did in SS, I think last class or SS3 or so, SS3. This one you have to what? Rationalize. You have to rationalize. If you are rationalizing this one, you multiply by the denominator in the same proportion. So 3 raised to power 2 over multiply by this raised to power. So this still 1. So it will end up giving me 3 raised to power. That is what I think 12. This gives me root 12. So this one gives me root 36. And eventually, I'll be having, this one can still be 4 times 3 all over 6 root 36 is. So 3 root of this is 2 times 2 root 3 all over 6. And of course I have 6 root 3 all over 6. So this 6 can cancel this 6. I have root 3 as my common ratio. I could try it in the second one, but then I believe this. So let me now look for what they ask us to check for. In its simplest form, the 80th term. Now, the 80th term will give us, like we normally have, AR n minus 1. So that's AR 8 minus 1. So it's going to give us AR raised to power 7. That's it. So we have our first term. Our first term to be root 6 multiplied by our common difference to be what? Root 3 all raised to power 7. So we want to deal with this. Root 3 raised to power 7, it means root 3 in 7 places. It means what? Root 3 in what? 7 from here. They said in the simplest form, that is root 6 is equals to multiplied by root 3 raised to power 7. The meaning of this is that root 3 times root 3 times root 3 times root 3 times root 3. 1, 2, 3, 4, 5 times root 3 times root 3. So this 2 will give me root 9, which is 3, times this 2 will give me root 9, which is 3. 2, 2. Okay, this 2 will also give me root 9, which is 3. Then we'll now have root 3 at the end. So if I should multiply 1, 2. Now, if I should multiply this 3, it's going to give me 27 root 3. 27 root 3. So meaning that this root 3 raised to power 7 is the same thing as this. So I'm trying to break it down so you know why we have 6 root 3 times 27 root 3. How we got this 27? This is the way we got it. Let me now continue from here. So it will now be equal to we can multiply in sort 27 root 3 times 6, that's 18. This will now be 27 root 18 is 9 times 2, and this one has root, that's 27 times 27 times what? This one is 3 times 2, root 2. This one will be root 2. Of course, this will give me 81 root 2. 81 root 2. Looking at this question, why I've decided to do many examples, because the question do come in different form. So the third term of a geometric progression is 24, and its seventh term is this 4 number 20 over 27. Find its first term. So now let's move on. We have they said the third term is 24. The third term will be this. I just want to move on this part 2. So, and they said it's 24 is equals to, they not give us first term and no common ratio. Of course, this is where we stop for the first term, that is equation 1. It's going to lead to simultaneous. So the seventh term is that. Now let's look at the seventh term. It will be AR, we just reduce this one by 1. So, and the seventh term is 4 whole number 20 over 27. So it will be R raised to power 6. Of course, this will now be our equation 2. So when you have multiplication, I want to combine the two equations now. Combine equation 1 and 2. So equation 1 will now be AR raised to power 2 is equals to 24. Of course, this one will be AR raised to power 6 is equals to 4 whole number 20 over 27. So now, in this case, it's different from the normal simultaneous equation that we do addition and subtraction, because there is addition and this one is now multiplication. So we do the division, we divide equation 2 by 1. We divide equation 2 by divide equation 2 by 1. Of course, this is equation 2. So it will now be A raised to power 6, which is equals to 4 whole number 20 over 27 divided by, and that division I will make it this way. 24. So it's going to give me this one. So let me divide this according to law of indices. When you are dividing, A is the same thing, and they are power 1. So it will be A raised to power 1 minus 1. So times the multiplication is in between. R the same thing, you now subtract the power, this and this. So division is subtraction. Check SS1 video. So this one will now be equal to 4 whole number 20 over 27 divided by 20. So this one, of course, this one will give me 0, because it's A raised to power 0 multiplied by R raised to power 4. This will eventually be, and this one is let me convert it. We say multiply this, add to this. So 27 multiplied by 4, this 28, take 2. This is 8, 9, 10. 10 plus 20 plus 20, 128. So it will now be 128 over 27 times 1 over 24. So this one is already 1. So the 1 times r raised to the power 4, which will give me. So if you multiply this, I think 24 can go in this direct. But let's make it small, small, something like that. Let's take it bit by bit. So 212, 264, 26, 220, 13, 2. So 212, 264. Okay, 26, 232. Then 2, I think that is 3, 2, 1, 16. So I'll finally have 16 over, if I multiply this, 81. So it's going to be r raised to power 4, 16 over 81. Then I take fourth roots. Take fourth root of both sides in order to cancel. Take fourth root of both sides. So it's going to be fourth root of r raised to power 4 and 16 over 81, the fourth root. So of course, this will cancel this. My common ratio will now be, which number will I multiply itself 4 times to give me 16? I think it's 2. And this one I think is 3. So this is my common ratio. But they asked us for first term. So I'll come to any of these equations to substitute for this. Let me take, as I say, substitute for r is equals to 2 over 3 in equation 1. Let's say equation 1, very simple equation 1, which is ar raised to power 2 is equals to 24. Now this r now is this, so it will be r is still 2 over 3 raised to power 2 is equals to 24. A multiplied by 2 over 3 raised to power 2 is equals to 24. Now the meaning of this is, if I like, I could open this up. A raised to power 2 times, that's 2 in 2 places, which is 4 over 9 is equals to 24. In order to get my A, I'll take division of both sides of the coefficient of A. So it's going to be divide both sides by 4 over 9. So that this 4 over 9 will be. So I say A 4 over 9 divided by 4 over 9 is equals to 24 divided by 4 over 9. So I'm taking this side divided by 4 over 9, this side divided by 4 over 9. So this one, if I reciprocate it, this will cancel out. So my A now will be equals to 24 multiplied by 9 over 4. So I'll reciprocate this as this changes to what? Multiplication. 4 here, 1, 4 here, 6, am I right? My A will now be equals to 9 times, I think that's 50. What? 9 times 4 is 45, and 9 times 5, 45. 45 plus 9, and that's 54. That's 54. So my A is what? 54. Now, by next video, God willing, we are going to go to sum of GP because it's different a bit. Do have a nice time from Pythagoras.